That is not an agent. That is a wrapper with a terminal. Look, we have a serious epidemic in the tech community right now. Everyone and their grandmother is slapping a simple Python while loop onto an LLM API, giving it a search tool, and calling it an autonomous AI agent. I mean, it's pure hype, right? If you want to build software that actually does work, without hallucinating its way into a fatal crash, you need way, way more than just a prompt and a loop.
Welcome to The Explainer. Today we are ripping the hood off a true engineering powerhouse, DeepSeek Harness, or DSH. DeepSeek just open-sourced the exact same framework they use to benchmark their insane V4 models. And let me tell you, this is not another weekend toy script. We're tearing down the architecture, auditing the security model, and putting it head-to-head with Anthropic's Claude Code. If you're a dev who's tired of the fluff, well, you're in the right place.
You know, the entire AI industry is completely obsessing over parameter counts right now, but we're missing the forest for the trees. The model is only one piece of the system. The real engineering problem starts after the prompt. Think about it. How do you handle file system edits without corrupting data? How do you securely execute a bash command? That is exactly what a harness does. It connects the raw, unpredictable brain of the LLM to the actual physical reality of a computer.
Getting started with it is deceptively simple. Assuming you already have Node.js installed, you just run npx @deepseekai/dshweb. But hey, do not let that one-liner fool you. You aren't just downloading a tiny wrapper here. You are pulling down a massive, complete TypeScript-based application framework that's engineered to manage the entire lifecycle of an AI workflow.
So, what does that do? That command actually spins up a local web UI right on your machine at port 3080. Now you might be asking, why local? Well, because when you are building agents that have the power to delete files or literally nuke your entire codebase, you absolutely need a safe, local sandbox to watch them work. Just plug in any OpenAI-compatible API key, and yeah, it doesn't even have to be DeepSeek, and you immediately have this powerful command center.
Let's actually peek inside the GitHub repo, because this thing is an absolute beast. First, you've got the apps directory for your entry points. Then packages, which is where the magic lives. We're talking modularized file systems, terminals, web scraping. There's a native folder packed with actual C code for Linux sandboxing, plus they throw in fully baked TypeScript and Python SDKs. Like I said, this isn't a monolithic script. This is a highly modular, enterprise-grade architecture.
Section 1. Core Architecture. Everything is a plugin. Unlike monolithic agents, where the UI, the tools, and the LLM are just this tangled mess of spaghetti code, DSH operates on one strict rule. Everything is a plugin. And this is powered by a microkernel called Cordis. It uses something called Spatiotemporal Composability. I know, it sounds like time travel, but it basically just means this. You load a plugin, it registers its tools. You remove that plugin, and Cordis automatically unwinds and cleans up all of its side effects. There is no hard-coded core you have to patch. It's just pure modularity. Because of this, the agent loop inside DSH is not just executing a function and blindly looping back. It follows a strict set of traffic rules. It assembles the prompt, sends the request, and crucially, it hits pre-policy and security guards. Tools actually have to pass through permission checks, timeouts, and concurrent schedulers before they even execute. It brings absolute order to the total chaos of autonomous code.
Think of it like this. Standard agent frameworks, they're like pre-built PCs. If you want to swap out the motherboard, you're pretty much out of luck. DeepSeek Harness, on the other hand, is a giant breadboard. Using a simple cordis.yaml file, you can hot swap models, rip out file system access entirely, or change how context is compressed right on the fly. It is infinitely composable by design.
And honestly, one of the best features here is the trajectory log. DSH has a strict rule: model visible means logged. Usually when you leave a standard agent running for 20 minutes, the chat UI just becomes a useless black box. But trajectory is this local playback window that captures event-level records of every single thing the model saw, requested, and executed. It's literally a flight data recorder for your LLM.
Which brings us to the elephant in the room. Is it actually secure? Because let's be real, giving an autonomous AI recursive access to your file system and a live bash terminal is terrifying. Just one hallucinated remove command and your entire project is vaporized. So how does DeepSeek Harness actually handle this threat?
Enter that native/landlock run folder we saw earlier. DSH utilizes native Linux Landlock to create a hard sandbox boundary for any spawn subprocesses. This physically restricts what the agent's bash terminal can actually touch on your host OS.
Now, let's be intellectually honest here. This does not guarantee bulletproof security in every single configuration, but it drastically reduces the blast radius. As a dev, you still have to configure your access policies wisely.
Section 2. DeepSeek Harness versus Claude Code.
Now, this isn't some silly fanboy battle. Both of these are incredible pieces of engineering, but they make very different architectural trade-offs. Claude Code is a highly polished, commercially integrated CLI product. It gives you an amazing out-of-the-box experience designed to just work. DeepSeek Harness, though, is a plug-in native developer's toolkit. It sacrifices a bit of that immediate, shiny polish to give you absolute, God-tier control over runtime composition.
For example, look at context management. Independent testing shows Claude Code injects around 23,000 tokens just to describe its 27 built-in tools, as it aggressively explores codebases. DSH takes a different route. It manages tools through its modular registry and offers a minimal mode. This exposes only Bash and a really simple editor, which vastly slashes your token overhead when you just don't need the agent to have complete God mode capabilities.
Section 3. Benchmarks. The last mile to economic value.
At the end of the day, the harness you choose is the last mile to actual economic value. Putting a great model in a terrible harness just wastes your time and your money. Look at this variance from independent Composio tests on 30 hard workflows. They use the exact same DeepSeek v4 flash model across the board. Paya achieved a 66.7% pass rate. OMP hit 56.7%. Claude, Code, and Deep Agents, they landed at 53.3%. Your success varies wildly based entirely on how the framework orchestrates tools and manages retries.
And this is where things get interesting. Let's look at the cost per successful task, because this is where your wallet really feels it. Running v4 Flash through Pi cost under 3 cents. Deep Agents, 4.5 cents. But Claude Code? It was nearly 20 cents per successful task. Why the massive difference? Cache misses. It only hit the prompt cache 1.5% of the time, which means you're paying full price for fresh input tokens over and over and over again.
Because caching is everything, right? During closed beta testing of the DSH local UI, developers reported a staggering 99% cache hit rate. With DeepSeek introducing peak and off-peak API pricing, maximizing your cache hits is literally the difference between a cheap automation run and a surprisingly massive API build. DSH is ruthlessly optimized to keep that context stable.
And finally, those massive benchmark scores DeepSeek published for their v4 Pro model, Terminal Bench at 87.9, Toolathlon at 74.1, they didn't get those by just casually pinging an API. DeepSeek officially states those scores were achieved running the model inside DeepSeek Harness using minimal mode. This codebase isn't just a side project, it is the literal engine that drove their state-of-the-art benchmarks.
Which leaves us with the ultimate question. The demo on day 1 is always easy. But on day 30, when you suddenly need to hot swap your LLM provider, isolate a runaway subprocess, or step-by-step audit a totally failed task, what does your architecture actually look like? DeepSeek Harness challenges us to build systems where everything is composable, reversible, and logged. It's open source, it's highly technical, and it's absolutely worth a clone. Thanks for joining me on The Explainer. Now go out there and build something awesome.